University of Texas Quest energy transformation problem. Crate pulled up a rough incline. Okay, this is a good problem talking about work, force times distance. This is what we're given. We're given a known mass that's being pulled up an incline by a known force. They say it's a rough incline, so that means we're going to have friction, and they give us the coefficient of sliding friction. They also give us the length of the ramp, and they give us this angle theta. Okay, so the first thing that they ask for is the work done by gravity. All right, well, we need to think the fundamental thing about work is what displacement and force are parallel to one another. All right, now we know the gravitational force acts straight down. Now, this has a two-dimensional displacement, but since this force is acting down, I am only interested in the vertical component of displacement. So since I know the ramp length and the angle, a little bit of trigonometry, I can get the ramp height. So it is this vector and this displacement that go together. Now I'm calling it negative because the force of gravity is down, the displacement is up. When we're parallel but opposite, we're going to have negative work being done. And if I'm not mistaken, we actually have to enter it into UT Quest as a negative. Okay, the next part is force of friction, or work done by friction. Okay, again, what I need is I need a parallel force and a parallel displacement. Well, where is friction going to act? It's going to act along this displacement, along the length of the ramp, which is given to me. So the distance part is not a problem. The force of friction part, we have to go back to our chapter 7. We have to remember that force of friction is equal to mu k times our force normal. And I know that my force normal is going to be in equilibrium with this perpendicular component of our weight. We know how to figure all that. So my force of friction is basically going to be mu k times this term right here for our force normal. And that's what we have right here. And the work done by friction is again negative. However, the question recognizes the energy as a loss. So we're going to enter this number in as its absolute value, knowing that it is negative, it is a loss. Okay, now work applied by the applied force. That's the easiest one because this applied force and the length of the ramp are both given. So I can just multiply these two quantities together. They're going in they're parallel and the same direction, so that's going to be positive. Okay, then things kind of get a little bit tricky. It asks for the change in energy. And the way we're going to do this is we know that by the work energy theorem, work is equal to change in energy. In this case, what is changing, what type of energy is changing in the block? Well, kinetic energy, because it's speeding up as it's being pulled down the ramp. And you might also say, well, potential energy is also increasing. Yes, but that is actually taken care of in this term right here. So when we put this term in here along with this stuff right here, we're kind of taking care of that change in potential energy. Not as directly as I like, but indirectly. Okay, so what we can do is you can just do an accounting of my work. So I've got a positive work applied. Some of that work is being taken away by gravity. Some of that work is being taken away by friction. So this then is going to be my net work, and I can sum these all up, and that is going to be equal to my change in kinetic energy, which is what they're asking for to enter in the next to the last answer. Okay, and then from there it says, okay, well, what is the change now in velocity? Well, if I know the change in kinetic energy, I can find the change in velocity. Remember, change in kinetic energy, my final kinetic energy minus my initial kinetic energy. Now, I know all these things. One problem I've noticed working with students is they neglect to notice that in the problem, I actually have an initial speed, therefore an initial kinetic energy. So they usually forget this term right here. Remember, these terms are squared. Do your algebra, solve for V final. And that completes this multi-part problem.